The newer motherboards come with the Type C controllers, and there are multiple Type C ports in the new generation laptop, like the 10 generation onward laptops. The power source is Type C, whether it is HP or Dell, and there are multiple power inputs. Like in a previous model laptop, there is only one power source, that is the adapter inputs. But the Type C laptops, there are multiple power source. There are two power source, three power source. In some laptop, there is a Type C ports also, as well as the traditional adapter ports also. So in this video, we are going to learn about the two input Type C ports, and how power flows and how the system voltage will be generated. Okay, so here we are going to understand the concept, and once you understand the concept of this Type C two controller ports, then you can able to repair new generation laptop, whether it is HP, Dell, Lenovo, or whatever it is. Okay, it's not a matter. So now you can see here, here is the two power Type C controller port. This is the first Type C controller ports, and this is the second Type C controller ports. Each ports have the individual controller chips. So here is a Type C connector, that is number one. This is number one. Have the individual Type C controller chips, and here is another port, Type C controller port, have the another controller chip. So there are individual chip for the each connectors. Okay, and their both powers are joined together. It's called the V system. Like suppose if I connect the power to here, then the CC bus will communicate with those Type C controller chips. Type C controller chips basically require a 5 volt, and that 5 volt generated by a buck converter. Once this buck converter started, it's given power to this Type C controller ports, and as soon as we connect the adapter to here, then the first thing happen is communicate with the CC channel. CC channel is basically a communication protocol between sender and the receiver. Okay, so here once the communication take place in the CC line, then the adapter generate or adapter deliver the voltage, that is it deliver the first 5 voltage, and that 5 voltage enter into the chips, and then this chips request 20 volts. So from this chips he asked, here is my SIO, then SIO requests this Type C controller to get a 20 volt, and then this controller chips request the adapter that is required at 20 volts. So from the CC line, that communication will take place, and then immediately adapter convert that 5 volt into 20 volt from the V bus line, and then from the V bus line, this Type C controller trigger this MOSFET. Here are the load switch. Load switch, that means there will be one MOSFET or two MOSFET which hold the voltages, is not allowing to pass other side, that means this side. Okay, so once everything is okay, then this Type C controller trigger this MOSFET, and then this voltage will pass to here, and then this voltage comes here at step number 3, and here across this R1, that is the current sensing resistor. Same thing happen here if we connect the adapter here. So same thing happen, that first the CC line will communicate with the Type C controller chips and the adapters, then the V bus will be generated, the V bus 20 will be generated, and that V bus entered into the chips, generate the so many LDO voltages, communicate with I2C bus. The I2C bus is basically a two-wire communication protocol between the Type C controller chips as well as with the SIO. Okay, so the 20 volt pass here, either you connect the adapter here or here, that 20 volt pass here. If it is a condition is not applied, then the 5 volt will be generated, and that 5 volt will come here. If everything is okay, then 20 volt will be generated, that 20 volt will come here, that system voltage, V system voltage. Okay, then here is my buck boost converter chip. Buck boost converter chip is basically a chip which buck converter means basically reducing the voltage, and boost converter means the increasing the voltage. So this circuit is basically reduce the voltage also and increase the voltage also. The in Type C, the special thing in Type C is that the power is a bidirectional. In our traditional laptop, there is a power is only unidirection. That means the power entered into the laptop and goes inside into laptop. But in the type C laptop, the power goes in also and comes out also. That means if you connect another laptop to the my working laptop, then one laptop can charge the another laptop. It's like that, or vice versa. That means power goes in the both the side. That means we can power entered into this port also, and the power goes output in the port also. That means the power come in and out also, both the way. Okay, so for that, here is a buck boost converter. I already told that the buck boost converter means, buck converter means decrease the voltage, and boost converter means increase the voltage. So for that, there is a dedicated controller chips here, that is called a buck boost converter chips, and this buck converter chips control this four MOSFET. Here are four MOSFET, two Q1 and Q2. Here are the two MOSFET, and here are Q3 and Q4, another MOSFET. And in between these two MOSFET, there is one coil, L1 coil, or inductor is there. Okay, so what happen is, so once this voltage 20 volt is passed here, that will enter into the chip. So this chips is basically a chips require a power and that power enter into the chips in the DC in pin, that is direct current in. There is a power to the chip, that will be the 5 volt. And after that, here is a voltage divider circuit. R3 and R4 are the voltage divider circuit, which generate a 3 volt here at step number 6, which will call the AC in. Here is the AC in stand for adapter current in, input. So here will be 3 voltage, and this 3 volt entered into chips. This is something like a trigger to the chips, that indicating that the adapter voltage is present. Okay, so once this get input to this 3 volt to this AC in pin, immediately this chip is activated and generate AC OK signal, that is adapter current OK signal, to the SIO. Once the SIO come to know that the adapter voltage is present, then from the I2C bus he started communicating with this type C controller chips and request to receive the voltage which is come from the adapter. So once this types I2C bus is started communicating, after that this buck boost converter started triggering this two MOSFET. Here are two MOSFET cascading, and this MOSFET are generating pulsating AC, switching the 20 volt, and that switching pulses will be passed to this L1 coil, and that voltage, that pulsating AC voltage, will come across this coil and stop here, because both the MOSFET are now in off state. So once that pulsating AC voltage come across this Q3 and Q4, then this buck boost converter trigger this Q3 MOSFET. Okay, so it's triggered, just simply turn on this MOSFET. So once you turn on this MOSFET, then that pulsating AC voltage which is generated here, that will be passed across this capacitor. So here is a filter capacitor which filter the voltage, and here the system voltage will be generated. That system voltage is approximately 12.6 volt, or depend it's model to model. This voltage is a variable. In some laptops require a 13.1, some laptops require 12.6. It depend model to model, but somewhere around that only. So the system voltage will be generated, that is 12.6. Now we given a 20 volt and my system voltage is a 12.6 voltage. That means this circuit reduce the voltage. Okay, so after that this voltage entered into the next section, that we'll see in the next. So how the battery will charge. So once this system voltage will be generated, here the buck boost converter started communicating with this SIO. Then what the SIO do is, he started communicating with the battery. Here is my battery. Battery have something 5 to 6 connection. One is a positive terminal, another is a negative terminal, then the temperature, then the battery detect, and there is a two connection is called the I2C bus, or called SM bus. So this I2C bus or the SM bus is a basically, I already told that this is basically a communication protocol where the battery tell SIO that how much charge there in this battery. That means how much voltage is there in the go down. So battery work as a go down. Okay, so here the battery tell SIO that how much their charge remain in this battery, and he requests he charge for this battery. So after that, here the SIO requests this buck boost converter that deliver the voltage to the battery so that the battery can be charged. Now this buck boost converter at step number 13 generate this signal is called a bad drive. This bad drive is the output signal which trigger this Q5 MOSFET, and once it trigger this Q5 MOSFET, here is a 12.6, that is the system voltage, which will pass from this Q to Q5 MOSFET, pass to this R2 current sensing resistor and entered into the battery, and the battery started charging like that. Okay, so in this way the battery charging. Now what will happen if I remove the adapter from either from here or here? So if I remove the adapter either from here or here, then the same battery voltage will be passed from this Q5 MOSFET and come across this system voltage, that is a B plus voltage or the system voltage. So this MOSFET work as a bidirectional. When you need a charge, battery need a charge, that time this chips trigger this MOSFET, generate a battery drive signal to its gate, and then the system voltage will pass from to drain to source and entered into the battery. And when we remove the adapter, at that time the battery voltage will pass through Q5 MOSFET and that voltage become a system voltage. So both the way our system voltage will be there, and my system voltage will be same. Like in our traditional laptop, our system voltage is different. Suppose we connect the adapter, at that time my B plus voltage or DC battery voltage is a 19 volt, and we remove the adapter. When the laptop works on the battery, at that time my system voltage will be the battery voltage. If my battery is a 12.6 volt or 13.1 volt, my system voltage will be 12.6 or 13.1. It's depend on the battery. So our system voltage is a different in our traditional laptop, but in the type C my system voltage will be remain same whether it is work from adapter or from the battery, whether it is here the 5 volt or 20 volt, whether laptop works on a battery, both the thing it will remain same. So friend, in this way you have to follow the steps. If the system voltage is not coming here, then what you have to do, you have to check here, you have to put adapter your type C adapter here, and you have to check here. If the 5 volt is stable here, is not switching to the 20 volt, then you have to see this chips whether this chips is short or what. If the chip is short, then you have to replace the chips. These chips have individual bias also for each type C port. So what happens sometime, this bias get corrupt. At that time you have to download the bias and you have to flash this bias, because each chips controller have their individual bias. Okay, so you have to see that. And sometimes these chips get short also, that time also the system voltage will be not generated. So now if I'm a system voltage is generated, suppose the 20 volt is coming here but the 12.6 is not generating here, then you have to entire focus in this chips. You have to see DC, you have to see AC in 3 volt, you have to see AC OK signal, you have to see this communication, that I2C bus communication. This I2C bus communications you have to see with the help of oscilloscope, because whatever the dotted lines shown here are on the pulses. So these pulses you can observe only with the oscilloscope or the signal analyzer. So if this communication is there, then you have to see this L gate and U gate, this both MOSFETs started triggering, 20 volts is started chopping. You have to see on the both the gate. If chopping is there but output is not there, in that case your one of the MOSFET may be open, and after that you have to see this Q3 MOSFET, and then the voltage will be passed output. So this I2C bus is a play a very important role in your previous laptop. What we did is, we just simply, if the voltage is not passed from here to here, what we did, we simply short this MOSFET. But in type C laptop you can't do that. You can't short straight away MOSFET, because here is a communication protocol is there. If the communication is not take place, then the voltage won't be accepted in the next level. So okay, so you have to see that. So now my system voltage will be generated. Now we'll see where this my system voltage passes. So we'll go on the next slide. So here is my next slide. The system voltage comes here. So here are my different buck converters. This buck converter is a 3-volt buck converter, 1.05 volt buck converter, 1.8 volt buck converter, for DDR4 RAM buck converter, then the 5-volt buck converter, and the CPU core buck converter. So these are the buck converter. This 3.3 have the two section. One is called the linear section, is called the LDO section, and this 3 volt is going to the SIO. So here's my SIO. So this voltage don't need any power on. Just once this system voltage 12.6 enter into these chips, then these chips generate the linear voltage called the VRG3, or it's called the 3VL, or it's called the LD voltage, that is a linear voltage, and that linear voltage entered into the SIO, and this the power to the SIO is called a 3 volt. And this 3.3 always voltage will generate only and after when we press the power button, and this voltage is going to the CPU, LCD, BIOS, and all the sections. This 1.05 voltage is basically is going to the PCH. That means in this types of laptop, the CPU and PCH is in single chips. So this 1.05 voltage is going to the PCH side, then 1.8 also is going to the CPU. DDR4 RAM. The DDR4 RAM require a 4 level of voltage, that is a 1.2 VDD, zero point 0.6 VTT, and 2.5 reference, as well as 3.3 is required. So DDR4 RAM require a 4 level of voltage. Then there is a 5 voltage. 5 voltage required to the audio amplifier, then the USB and the fan and the VRM chips. And the last is the CPU core voltage, which is given to the CPU core section, that is the CPU core. Okay, so in this way, this Type C controller system work. Simply you have to follow the steps, watch this video again and again, and understand the concept, and then you can able to rectify problem in not powering on Type C laptops. So thank you very much.